Hello guys and welcome to this new tutorial. First of all, I created a Twitter account so you can follow me there, and yeah, I will post there R&D stuff, renderings, upcoming tutorials, Patreon stuff and so on. So hit me up there, leave a line at timjdesign. Cool. Today I want to talk about I think a pretty cool topic, Vellum hair. This is just a little bit R&D here, and we will do R&D now with Vellum hair because I think with Vellum hair you can do a lot of cool stuff, especially in the motion design field, with fabrics, abstract hair, abstract lines and so on. And I really like this field because it's pretty good art directable and controllable, and with simple lines you can do really a lot of things, and I really like that. And I think we will get started now. So I created here a geometry container, but let's create it from scratch. Okay, press tab and place down a geometry. I will give it a black color and a round shape here and call it GeoVellum R&D. Cool. Then we can dive inside with double click. And first of all, we need a base for our hairs. For our hair setup. First of all, let's get a sphere. So just let's go basic at the beginning. So place down a sphere. I enhanced or dialed up the frequency a little bit, and now I want to scatter some points. Let's scatter some points here. So now 1000 points onto the sphere. Let's make it 150 for now. That will be our final hair count. And before that, I want to place down a normal on the sphere, and I want to place the normals onto the points, so they will get transferred with the scatter sub. And you can see here, without the normal node and with the normal node, we've got point normals directing outwards. Cool. So we got that, and I want to place down a null to keep it organized and call it in PTS hair. Now I want to place down a copy to points because I want to copy strings or lines onto the points here. Let's get a line and connect it, and now we can see we already got something abstract. We got some lines here, but they're not at the right direction. So maybe you want to get this direction, but I want to point them outwards, so you need to get it to the right position, and you will need to place it flat on the Z-axis. So let's place it flat here, and now you can see they will point outwards. Cool. We got our line. Now we can resample the line a little bit, and let's make it longer. So length 2.5. We will make a resample. 0.1 is fine for now, and we will create the curve U attribute. For everyone that don't know what a curve U attribute is, it's basically a float value along the line from 0 to 1. That's a curve U attribute, and you can do a lot of cool things with the curve U because you can manipulate points with the curve U in connection with p-scale or rotation and so on. So curve U, make it lay flat on the Z-axis, and now copy the points. I will just disable the visualizer for now, and now we can place down a group expression because I want to basically attach the lines onto a single point. So we will create a pinpoint, and that pinpoint will be static in the simulation. So I will type here in group name $OS, so the group name will get the subname here. Let's call this GRP for group and pin. We will change the group type to points, and then we will type @curve u equal 1, and we will get 1 point here, but I think that will be the wrong point. Let's place down a Vellum configure hair and dial our here by pin to animation. Let's get a group, and yeah, the group is outside. You can do that too for sure, but currently I want the group inside, so let's type 0. And now you can see that we placed our pin group, or the group here above on the inside from the lines, and they will be now static. So if we now make a simple simulation here, so Vellum solver, let's connect the Vellum solver here, wrong connection. And when we connect it here, now we can already see the hair will just fall down. That's also pretty cool, and you can see the collision between each hair. And yeah, cool. First of all, I don't want gravity for now, so let's cancel out the gravity here. And now when we press play, nothing will happen, because we got no forces. And now I want to get some forces in here, so dive inside the Vellum solver, and we will place down, for example, I tried it a few minutes ago with the pop axis force. With that you will get some pretty cool results. You will get something like this, and it will twist and twist and twist, and especially here above, I think that's pretty cool. Yeah, maybe that will looks currently like maybe a bacteria, something like that. So the cool thing is now you can dial up your hair count. So let's make 500 for now, and let's simulate that again. Oops, let's make it real time here, or not real time, but so you can see the process. Yeah, with 5000 it's of course much slower, but you can see the pretty cool complex structures that will appear just with a single axis force here. Cool. Let's make it 500 for now and simulate it here. It looks like from a butterfly, a cocoon that will wrap up the caterpillar. That's pretty cool. Another thing what we can do, so we tried out the pop axis force. Let's dive up, and I want to get another base geometry, so I will use a grid for now. Let's place down a grid here. Cool. Let's make it a little bit smaller, so I will choose 2 by 2 and scatter the points on here. And now with let's try now the Vellum, the pop axis force. And of course now you will get this also pretty cool like flowery effect. And of course they will get twisted here, so I think that's pretty cool if you got if you go now in here with some detail shots, I think that's pretty nice too. And of course this, yeah, like this flower shape, that's pretty cool too. Now I want to use, let's use a simple pop wind with an amplitude of 0.5, and I want the wind go into the up direction, so 1 here. Let's try that out. Yeah, you will get like grass or seaweed underwater. That's pretty cool too. But now let's disconnect this and make a simple custom force. So you can place down a pop wop in here, and you can dive inside a pop wop. And for example, we can use let me just get here constant, and I will use a vector, and I will point in the x direction, velocity, and that's basically, yeah, a simple wind, but it's like a wind with no frequency or noise. And what we can do now, we can dive back inside and place down, for example, an anti-alias noise, get the position, get the noise into the velocity, and make it a three-dimensional noise. And we can multiply that, for example, multiply this with that. And now you can already see we've got here a noise field that goes slowly into in that direction here. So yeah, with some custom noise fields or forces, you can also do a cool stuff. Let's cancel out a constant here and just use the single noise here, and we will combine that with the pop wind. So pop wind going up and maybe to the side, and I've got an amplitude of 0.75 for now, and I will go away from the 0 offset, and let's simulate that. Let's make the wind a little bit stronger here. .1 and 0.5. Okay, I think that's too high, 0.65. And now you can see both forces interacting, so the pop warp force and the pop wind force. And I really like this, yeah, it got a really organic look, I think. So let's make random hair length. So we can do that with a simple, with a really simple technique with p-scale. So I will place down an attribute wop, and we will use a random. We will use the pt num, and we will get a random value between 0 and 1. Now we can fit that value. For example, between 0.25 and 1, and bind that out to the p-scale. And of course you can do that in wax, but just for the new people out here, I want to do it in WOPs. And yeah, we got that now, so we got a p-scale, so you can get up over here and make a visualizer for the p-scale, for example. And now we already got different length, and I think that will look much more organic or pleasing to the eye. Of course you can do it in Vex too, so I will do it in Vex quickly too. So we want, with Vex, we want first of all the random, and the random is pretty simple. We can type float, because we want a float value. Let's call it rand, equals rand, open brackets, at ptnum. Then we can use, for example, seed, so times channel float seed. So we got our random value with the seed, and now we want to fit the random value. So, for example, at p-scale equals fit 0, 1 rands, and we want to fit that between two channels, so between a min channel and between a maximum channel, max. And now we can fit it, and we've got the same result here with a seed value. So that's the Vex way, and this is the WOP way. So you can do it in Vex or in WOPs, it's fully up to you. Cool. So we got our simple simulation here, and let's style it. I think we should get a little bit of imperfection into the ground. So I will use the grid for that. I will you can drag and drop parameters. For example, here rows, drag and drop to columns, and now we can press relative channel reference and it will reference the rows channel. I will dial that here a little bit up, so maybe 100 by 100, and we will use a simple technique to create our own simple terrain environment, just pretty quick and dirty. Not an anti-alias parameter, but I want anti-alias noise. Let's get a position, and we will displace the position along the normal. So displace along normal, where is it? Displace along normal, here. We will use that for the amount and the position to the position, and we will bind out the displace position to the position. Let's get rid of the zero offset, and I want to get a little bit down with the roughness, and I can get a little bit down with the scale. So we will get a little bit of simple terrain here. Of course we can do it like that, and now we need much more hair. 5000, and you can simulate that too. So let's do 1000 for quicker preview, and you will get already this dynamic hair field, or whatever you want to call it. Cool. Now what we can do, for example, let's do a ring. I think ring. Let's list out a circle, not a ring. What I want to do, make it a polygon, make it an open arc, type 46 divisions, and I will use a polyframe to direct the normals, and we will use the tangent for the normal. No, let's use the B tangent for the normal, and the B tangent normal will go outwards, and we can use a fuse if we don't want to no, wait, where was it? Oh, mark. Yeah, okay. Now we can use the scatter here, basically the same setup, scatter, and let's disable the relax iteration, and now we will copy hair or lines onto our circle. And already with this technique you can do a lot of cool futuristic UI stuff, but we will use it now for our solver. Okay, let's dial our wind velocity, our up direction, a little bit down to 0.25, and let's get a swirl size a little bit smaller here, and let's have a look. Yeah, that looks pretty cool. For example, you can do it in reverse to open something or reveal something. That looks pretty cool. Okay, let's get a circle here, and what I want to do, that's pretty simple but pretty cool, copy and transform. So we will copy and transform the circle with a uniform scale a few times, for example 4 times. We'll scatter the points on here. Let's make a little bit more. And now you get a much more complex structure. And of course you can now merge the previous circle with the simulation to get a polyframe in here or polywire to get even geometry. Another cool thing what I like to do with lines is to convert them into a VDB. So we will use that. We will place down a resample here now. Place down a resample and make 0.01. So I will show you some techniques. What you can do, you can use a resample with a smaller amount of points, and you can pipe in there a wireframe and control the radius here a little bit. And I want to get a little bit of intersection here. That looks pretty cool. And what we can do now, we can remesh the whole thing. So VDB from polygons. Let's convert that to a VDB. That will take a little bit. Okay, so we got our VDB here. Something like that. And now we can make a smooth VDB. Smooth VDB. And we can convert it back. Convert VDB. Convert it back to polygons. And now you will get something like this. So that's a pretty simple technique to get pretty cool structures. Of course you can cache it out like a simulation, and I think that looks pretty cool because you got this pretty organic look, but you also got like a structure in there. You got the circles, you get the interconnection between circles and so on. So I think that's a pretty cool setup to get corals, abstract flowers, stuff like that. Another technique would be, maybe that will work too, you can, let's get 0.25 here and place down a VDB from particles. And I will go down with the scale and down with the point radius size here. Oh wait, we need to, let's attribute delete, let's delete every attribute currently on here. So star, star, because we got the p scale on there. And now you can play with the point radius scale, and I think that would be a little bit faster than the wire stuff. Yeah, it will be faster, and you got pretty much the same result here. Cool. So you will get something like this. And of course now you can, oh yeah, let's do that for now. Let's displace the circle here. Okay, let's do that. We already got the normals pointing outwards, so we only need to do, what we only need to do is to place down a WOP, an attribute WOP here, dive inside, get the position, get a noise for example, and displace the noise, or displace the normal with the noise along the position, and you will get something like this. And let's dial up the resolution here, and we can copy that. Of course you can, what you can do, you can, let's just do that. Okay, let's do it. I got an idea here. What you can do, you can go in here with a loop, so for each connected piece we will go over each piece with this noise here, but we will expose our offset parameter with a parameter here. Let's get an in the offset, and let's call it off and off iter for iteration. And now we can control here our offset, but I want to control the offset with our metadata here. So get on the first node and create meta import node and call it meta. And what we can do, we can press right click, reference scene data. Let's go into the object, into our Vellum Geo Vellum R&D. Hello? Houdini? Okay, oh, now it's, yeah, it's sometime it will take a while to open. And you can go to our meta, where's our meta? Here, and attributes global iteration. So on each loop iteration we will get a random offset, or you can do it like that. I like to do that here. Go to, let's just delete them here. Go to our attribute WOP, go to the gear here and select add spare input. Now drag and drop the meta in here, so we will get this purple dotted connection. And now we can just type detail, open brackets, -1, that will be our spare input, and then the attribute or the detail attribute you want to call, so for now iteration, and comma, and you will get the same thing. So that's for that, and now we want to connect that. So we will get like basically a fully random offset here on each circle, and let's simulate that for now. Let me have a look at the time. Yeah, easy. Cool. So let's simulate that, and let's pipe that into our convert setup here, and we will get a little bit more, yeah, displaced or imperfected shape. Looks pretty cool. Okay, cool. Now let's get some simple rendering started. I will use the uniformal circle for now. You can also do a geometrical rendering, so use the this geoconvert, but I will use the lines for now. So let's bump that up here. Let's go 5000 and let's simulate that. To some frame that I like. Okay, let's simulate it a little bit further. So the cool thing is you will get all the, for example, for hair, all the collisions. Maybe you need to polish it, so you will, yeah, need to manipulate your parameters or your settings a little bit in the Vellum solver. So for the maybe the collision passes and constraints iteration, and maybe 2 or 3 substeps for larger simulations. Now we got that. Let's pipe that here out, so null, and let's call this out hair. Cool. So we got that. Let's copy our attribute delete here, because I don't want any attributes on there. Let's just delete everything here. So we got only the P and of course the groups now, because we didn't delete the groups, but now we can resample the whole thing here. Oh, let's get a resample and dial in the curve view. So we will get our curve view attribute back on here. And now dive up, go to redshift object, or let's just first set up our material network. So let's call it mat rs mat, and we'll need a rob network. So rs out. I will color them both red because redshift. Let's place a redshift custom in here. System enable them. If you got a RTX card, you can enable optics RT. And let's get the global illumination. I will call this rs out 001. Then dive into the material network, place down a RS material builder, RS mat hair, and just leave it for now. Then we will need our material, so press for example Shift W and you can find your material in the mat context, drag and drop it in here. So the material is connected, and now we need to go to redshift obj, so the parameters from the object, to strands, render object as strands, and cancel out here the max tessellation subdivisions, and global scale multiplier, let's use 0.1 because we don't got p-scale for now, but maybe we will do that too. Let's create a camera. And we need some light, of course. RS light dome. I will choose a simple HDRI map. HDRI, let's get that one. Okay, cool. And of course make it yellow because it's a light, and call it RS maybe dome 001. Cool. Now we can start up Redshift. And let's clear that one. And go to Rec 709 for now. And you can already see our hair here. Cool. I will disable the background for now. And what I want to do, let's go, not strips, let's go cylinder. I think that will take a little bit longer to build. Okay, it's pretty fast. Yeah, with 24 gigabyte of GPU RAM, it's pretty good to have such a high amount for something like that, because you can iterate much faster. Many of you ask about the bokeh images. I will make soon a photography tutorial about the bokeh images, how to make them and how to use them then in Redshift. I will do that in the future because many of you ask, and I think that's also a cool topic to cover with photography in combination of 3D design. Cool. Now I want to get a sampling here for the focus distance. Select the focus distance, copy parameter and paste relative reference in here. And the COC radius, let's dial it down to 0.1. And I want to set the focus distance here. And let's start the Redshift render view again. And you can already see we've got a pretty simple but neat setup for rendering, so you can go in there. Let's try to pick the focus here, but so I think, guys, I need to focus manually. Let's get in here, and I will go out of the camera, get the focus here manually. And what I want to do, yeah, let's dial the bokeh power a little bit up, and let's go to aspect of 2. And let's go into the material, and now you can of course play around with the material. I love copper because it looks really cool, and of course you can now play around. Yeah, sure. Let's get the. I want to get our curve view here involved. So we already got a curve view, and dive inside to the material setup and place down a RS color user data. Just type it for now in the surface, and type in curve view. And you will see we will get our ramp from 0 to 1 or from black to white, and we can use our ramp, for example, preset copper, reflectivity. Let's pipe that into reflectivity. And now I want to place down a ramp, and with the ramp we can now influence our reflectivity based on our curve view attribute. For example, from white to red. Cool. And now you can get other base forms, play around with the amount, play around with the length of the vellum hair, with the parameters, with the forces, and I think you will end up with a pretty neat little setup. So that's that for now, and yeah, check out my Twitter. I will post some R&D later with this kind of setup, and I will see you in the next tutorial or in the next course, and stay safe and bye.